dx dt equals to ax is not equivalence clause. So up to ax equals to b in the first case. So we have started dx dt equals to ax, and this is x is a vector, A is a matrix, and x is a vector. And this type of system, we have seen the example in main example is chemical reaction engineering, or we have some system where temperature, concentration all change with time. Temperature, concentration both are changing with time, and system is linear system. So any linear system, and we have multiple variables, linear system with multiple variables, linear system with multiple variables, we can actually represent by dx dt equals to x. Linear system with multiple variables can represent with dx dt equals to x. Okay, so I have picked up example for chemical reaction engineering with the first order chemical kinetics, but it is possible to have the system for the simultaneous mass transfer, simultaneous mass and heat transfer, and also there could be multiple variables, they are changing with time, and for that case it is possible to have the dx equals to x. And we have seen the solution procedure for Ax equals to b, and it is possible to have the Ax equals to b solution in terms of eigenvectors. So we have seen the solution in terms of eigenvectors, and eigenvectors form the basis especially for the distinct eigenvectors. So eigenvectors form the basis, especially for distinct eigenvectors. Okay. So now, when you want to solve the dx equal to ax, first I will discuss that situation where solution of dx equal to x. First I will discuss for distinct eigenvectors. And matrix could be symmetric, could be non-symmetric. Matrix could be symmetric, matrix could be non-symmetric, self-adjoint or could be non-self-adjoint. But remember that distinct eigenvalues first we will consider, first case. We will be showing dx dt equals to ax. Even the worst case, when your eigenvalues are repeated and matrix is non-symmetric. That is the worst case. Worst case is matrix is non-symmetric and eigenvalues are repeated. That also we will discuss. But this is simple case distinct eigenvalues, because we know that the eigenvectors are orthogonal for symmetric matrix. Eigenvectors are linearly independent for non-symmetric matrix, provided eigenvalues are different. If the eigenvalues are not different, in that case it is possible to have generalized eigenvectors for the non-symmetric matrix. Right? That we have done. So first case is the easy case where we have distinct eigenvalues. So I will look into the solution process. Before that, I will go to the situation here where dx dt equals to ax, for example. Okay? Where this kind of equation you have seen in your school level calculus, first problem you have. And what actually happens? What is the solution here? X equals to what is that? Any hand please? Any hands please? Not equal for it is C, E, equal to. I don't know. I'm not getting the complete answer from you guys. Is it not C? How to get C? How actually? Why it is C? Because if you look at dx by x at You do integration, and this is the integration constant. So instead of c, we put ln c, the integration constant. So it is ln x equals to at plus ln c, and we have ln x by c at, and it is nothing but x equals to c e for a. I think this type of things you have done. I am really surprised that we have forgotten this one. Okay, fine. So, but here the solution is not unique because C could be anything. So for that purpose, we need to have condition. What is the condition you require to get unique solution for this case? At time t equal to 0, at t equals to 0, we need to specify, and quite often we say x equals to x0. So if you put time t equal to 0, what will get x0 equals to c e to the power 0 is 1. So x0 equals to c, and your solution is x equals to x0 e to the power a. Your solution is x equals to x0 e to the power a. Right? So now you can see this type of problem will be having the unique solution. This type of problem will be having unique solution. If t equals to 0 condition is actually given. So at time t equal to 0, condition is the must, and that is quite easy to give. You can say, sir, I can give time t equals to 5 seconds or 10 seconds. For example, we are having a batch reactor. In a batch reactor, it is possible to have the concentration measurement at time t equals to 0. Whatever reactor you are giving, you actually can easily measure. At 5 seconds, 10 seconds, or 1 minute, reaction going on. How will you measure concentration? How to measure concentration is very easy. You take the sample and do the titration and get the concentration measurement. That is easy at the time t equals to 0. At time 5 seconds or 10 seconds, it is very difficult to measure concentration. Very difficult to measure concentration. So, what actually happens? So, this type of problem in chemical engineering perspective, we need to have time t equals to 0 requirement. And this type of problem is known as IB initial value problem. This type of problem is known as IB or initial value problem. This type of problem is known as IB or initial value problem. Okay. So this type of problem is also known as IB. So now the point is, here x is one single value. It could be temperature and concentration simultaneously changing. So in that case, this equation will boil down to dx bar by dt equals to ax, where a is the matrix, here a is a scalar quantity, where everything is scalar. Well, this is vector, this has to be a matrix, because vector and vector multiplication will lead to things. One is scalar or it can lead to tensor. We have not discussed that part, because if we multiply two vectors, for example, we have one n by 1 and n by 1, two vectors are in row, one column. If you multiply, you cannot multiply just like that, because this gets row, column, this gets row should be. So n by 1 and 1 by n, it will lead n by n. It will lead n by n. So two vectors you can multiply, they will give matrix for this case. Or if you put 1 by n and n by 1, it will give scalar. So this has to be matrix. Okay. Otherwise you won't get vector. So vector and vector multiplication cannot lead a vector. It will either lead a scalar or tensor based on the properties. So that's why this has to be matrix, and we have seen also how this matrix comes for different examples in chemical engineering. So this type of problem is known as IVP, initial value problem. Initial value problem. And now we'll be trying to solve. When it is matrix, the procedure is not that straightforward. We can also follow this type of procedure, but this is possible to have IVP. This when you have dx dt equals to ax, it is possible to have solution in terms of eigenvectors. It is possible to have solution in terms of eigenvectors. It is possible to have solution in terms of eigenvectors. So, how to have the solution in terms of eigenvectors? So, let's look at the So this requires a condition which is x bar t equals to 0, x0 vector. Initial condition. X bar t equal to 0, x0 is the initial condition. Okay. So now, we have done this eigenvector decomposition. That's what I taught you. In Ax equals to B, eigenvector decomposition looks like a bit tedious. Okay, this looks like a bit tedious because you can ask, if I can directly solve Ax equals to B, why to find out eigenvectors and get the solution in terms of that, because we have to find out the alphas. But that method would be very helpful to solve this type of system, what I am going to demonstrate right now. Okay, so what we will do here, what we did, we assume the solution was alpha I q I bar, where q I are the eigenvectors and alphas are the constants, right? Because we know that any vector can be expressed as a linear combination of basis vectors, and we are saying we are actually having matrix which could be symmetric, could be non-symmetric, but the eigenvalues are distinct, and in that case it is definite. Those eigenvectors, either they are forming orthogonal basis vectors or linearly independent basis vectors. That's what we have learned. Okay. So now we have a situation where we have dx dt equals to ax. So in that case, this x has to be the function of time. X is a function of time, it's changing with time. So in that case, if I write in terms of, and also is a vector, so you can write this as also as a linear combination of basis vectors. But this is a function of time. In that case, out of this, which is function of time? What is that? Which will be function of time? Huh? Huh? U bar of I is what? Is eigenvector. Eigenvector can it change with time? What eigenvector? This is the eigenvector of matrix A. Is that matrix changing with time? It's a constant matrix we have seen yesterday. If we look at your reactions, A1 going to A2, A2 going to A3, A3 going to A1. We got a matrix in terms of K1, K2, K3. And K1, K2, K3 are the rate constants. Are they changing with time? They are not changing with time. And that matrix eigenvector is Ui. Can it be function of time? Eigenvectors cannot be function of time. If it is function of time, they are not the basis vectors. Basis vectors are the vectors which are unique, which cannot change no matter what happens. Basis vectors are the vectors which cannot be changed with time or cannot be changed with anything because they are the basis vectors. So anytime, any vectors can be expressed as a linear combination of basis vectors. Okay. So what will be the function of time in that case? The left hand side is function of time. Right hand side also has to be function of time. Alpha I t. Okay. Alpha I t. So in that case, since alpha I t, so let's proceed further. So we will now have the process, same process what we did, the same way we will try to find the solution for this case. So we have dx dt equals to ax, and now we can write, we replace x by x vector by summation I equals to 1 to n alpha I t u I. The eigenvectors A summation I equals to 1 to n alpha I t u I. Okay? Right? Is that clear? And then what actually happens? We can take the differential operator within the summation, and u I bar is not the function of time, so only the function of time is alpha I t. So we can write this as summation I equals to 1 to n u I bar d dt of alpha I equals to, you can write this as summation I equals to 1 to n alpha I t a u bar. Right? Okay. You can write alpha I t a u bar. Okay. And then we have the situation, you know that this is the eigenvalue problem. Okay? If ui is the eigenvector, corresponding eigenvalue is lambda. Right? If ui is the eigenvalue, eigenvector, corresponding eigenvalue is lambda I. Okay? So summation I equals to 1 to n ui dt of alpha I t summation I equals to 1 to n alpha I t lambda I ui. Next step you can write summation I equals to 1 to n dt of alpha I t minus lambda I alpha I t I equals to 0. Can I write? Just simple side change, nothing else. I have done simple side change. Right? So now you can see that if we compare our situation, long back I have discussed about the basis vectors property. Summation alpha I u I bar will form the basis provided all alphas are 0. In that case, if you consider this is like beta I, this is like beta I, u I equals to 0. That means this already formed basis, you know that, because that they are the eigenvectors. Okay, so beta I has to be 0. Okay, so in that case, we have dt of alpha I t minus lambda I alpha I t equals to 0. Right? So what is alpha I t? So it is a simple differential equation. The simple differential equation, like your dx dt equals to ax kind of thing. So you can see that the dx dt equals to ax, that kind of situation is possible because we have done eigenvector decomposition. Otherwise this wouldn't have been possible. So dx dt equals to ax, that kind of situation is possible because we have done eigenvector decomposition. Right? So what we can get from here? What is alpha I t? So, and this requires initial condition. So I am saying at t equals to 0, alpha I 0, alpha I t equals to alpha I 0. Okay. At t equals to 0, alpha I equals to 0. And how to get alpha I 0? This has to be known. This has to be known. Otherwise you won't get any solution. So now if you come here, you see x bar 0 is summation alpha I 0 u I bar. Right? How to get alpha I 0 from here? Okay. So there are two cases. First I will discuss symmetric matrix where the ui's are orthogonal. So if you take the inner product with respect to ui, we get alpha I 0. So for symmetric matrix, we have alpha I 0, which is inner product x bar 0 u I bar divided by u I bar. Am I correct? Yes or no? Yes. So alpha x0 is now obtained. X0 is the initial condition, okay, which is known. I am supplying time t equal to 0. What is the temperature? What is the concentration? ui is the eigenvector. It is known already. The denominator is also known, right? So in that case we can get upwards. In that case we can get upwards. Okay. So what actually happens? So alpha I t, which is alpha I 0 e to the power lambda I. Am I correct? Yes. If you don't understand how to get it, which is alpha I t, which is c e to the power lambda I t from here. And if you put alpha is 0, c is alpha is 0, and that's what we got alpha is equals to alpha is 0. If you got lambda, right? Now alpha is 0 is obtained already. Okay? Lambda and the eigenvalues, of course. So in that case, what you do? Okay. So your x bar now x bar t, which is summation I equals to 1 to n alpha I 0 e to the power lambda I t u I bar, right? So this is my final solution. So dx dt equals to, so eventually we have solved dx dt equals to x, where x is nothing but I equals to summation I equals to 1 to n alpha is 0, which is obtained from here, e to the power lambda I t is the eigenvalues, you are the eigenvectors, you are getting the function of time. So if you put different time, you get the answer. Okay? So this is the way one can actually solve dx dt equals to ax. So now, how to test this technique? You need to test this technique at a school level mathematics. So, if you want to talk in terms of school level mathematics, we have already seen this type of system. So, let's talk about pick up school level mathematics and try to see how you can visualize d2y dx square plus b dy dx plus 2y equals to 0. You have seen this is school level mathematics. Okay. What are the solutions? Trial solutions here. What are the trial solutions for this case? You need to solve this, and you have solved this problem at the school level. So a1 and m2 are minus 1, minus 2, right? Yeah. So what is the solution? Final solution? Am I correct? Yes. So now this type of thing can you have by this technique? That means what I am saying, this is second order differential equation. Can I have this as two first order differential equations? So in that case, my capital X vector will be y and dy dx. Okay? Of course, I have initial condition y 0 and y prime 0. I have, say, y. These are conditions given. And this is possible if this problem is IDE, initial value problem. That means all the conditions are given at x equals to 0. Okay? That's what I am saying. This one initial value problem. I have given all conditions at t equals to 0. Right? So, now my question is it possible to solve this as dx dt equals to ax, where my t is nothing but small x, where t is nothing but small x? How to write it? How to have the two differential equations from one differential equation? How to write two differential equations from one differential equation? How to write two differential equations from one differential equation? How to write two differential equations from one differential equation? So I'm defining this as z. Okay. So dy dx equals to z, right? And dz dx equals to d2y by dx equals to minus 3 dy dx minus 2. That means minus 3z minus 2y. So we can write this as dy dx dz dx equals to 0, 1, minus 2, minus 3, y, z. Am I correct? Yes or no? Yes. So this equation we have expressed in terms of two first order differential equation, and these conditions are already known. That means we know y is 0 and z is 0. Okay, correct? Yes. Yes or no? Yes. Yes. Okay. Now, if we look at the eigenvalues, what are the eigenvalues? What are the eigenvalues here? What are the eigenvalues? Minus lambda 1 minus 2 minus 3 minus lambda minus lambda minus 3 minus lambda plus 2 equals to 0. So you get 3 lambda plus lambda square plus 2 equals to, am I correct? Okay. So you get lambda equals to minus 1 minus 2. See? So now we can see this minus 1 minus 2 are nothing but the eigenvalues of the corresponding matrix. Now we can see the minus 1 minus 2 are the eigenvalues of the corresponding matrix. So that was the philosophical perspective. Why we do like this? This is the way. So these roots are nothing but the eigenvalues. Okay. And now how to get solution? So you can pick up some of the conditions here, and then we can go by the same process. Summation alpha is equal to the lambda I t, and you can get solution. And then you can get the solution. So this is the way one can look at this problem. So this type of problem already we have seen. It is not the first time we have seen. This is the way we have seen this problem. This is the way to explain. Now we got the eigenvalue. You find the eigenvectors of this. And this is non-symmetric matrix. You get linearly independent eigenvectors. Now I will discuss for this type of system how to get solution, because this was possible only for the symmetric matrix. For non-symmetric matrix, for this case, how to get solution? This will be our next agenda. So let's look at the non-symmetric. So no matter this, up to this, your process is okay. Only how to evaluate alpha is 0, that depends. Your matrix is symmetric or non-symmetric. So this process up to this is okay. It doesn't matter if your operator is symmetric or non-symmetric. You look at the total derivation. It is actually coming, x bar is nothing but alpha I t ui bar. I can write if they form the basis, no matter they are orthogonal or they are linearly independent. They are forming the basis, and we have seen that for the non-symmetric matrix or symmetric matrix, for distinct eigenvalues, the eigenvectors form the basis. Right? The eigenvectors form the basis. Okay? Now, what is the situation? Your situation is how to find alpha I0. Situation is how to find alpha I0 for non-symmetric matrix. How to find alpha I0 for non-symmetric matrix data. Okay. Look at this part. We have x bar t equals to summation alpha IT u I bar. I equals to 1 to n, and they are linearly independent. They are not orthogonal. Remember that if we put x bar 0, we have summation I equals to 1 to n alpha I0 u I bar. Right? Alpha I0 u I bar. You have to find out alpha I0. How to find out? Oh yes, exactly. Thank you. So inner product of x bar 0, then v bar I t, sorry, v bar I equals to summation I equals to, it should not be that, it will be alpha I0 inner product ui v I bar. We have done for complex. So these eigenvectors will be orthogonal for the of the eigenvectors, the complex conjugate system, and we have already done. So your alpha I0 will be inner product x bar 0 v I bar divided by u I bar v I bar. Correct? Correct? So alpha I0 is nothing but inner product x0 v I bar divided by u I bar u I v I bar. Okay? Conda is clear? So we have now found out alpha I0 for the non-symmetric matrix as well. So now with this, is it possible for you to solve? With this, it is possible for you to solve. I think it will be possible for you to solve. So in that case, what will happen? How to solve this system? So this is the what I am referring. I am referring to school level problem. Now we have learnt everything. I am taking every part. What I am taking? I am taking your class 2 level differential equation, which we have done. d2y dx square plus 3 dy dx plus 2y equals to 0, right? And then initial condition y x equals to 0, I am putting as 1, and z x equals to 0, I am putting 0. Can you get me solution? First of all, based on your school level, I want the solution from your school level. I want the solution from school level. First, you have to understand this problem. Then I will go to the assignment problem. I am taking up your size. As I said, whatever you are teaching in the class, you should put it in class 2 level mathematics. That is the best way, because you know this solution, right? What is the solution? The solution was y equals to c1 e to the power minus t, c2 e to the power minus 2t. Am I correct? It's school level mathematics, nothing else. And dy dx is what? Minus, sorry, e to the power minus x. c1 minus c1 e to the power minus x minus 2c e to the power minus 2x. Am I correct? So dy dx equals to, at x equals to 0, will be, it is equals to 0, which is minus c1 minus 2c2. So we have c1 equals to minus 2c. Now if you look at the initial condition at y at x equals to 0 equals to 1, that means 1 equals to c1 plus c2. Am I correct? c1 equals to minus 2c2. That means minus c2 equals to 1. So c2 equals to minus 1, and then c1 equals to plus 2. So your solution is y equals to 2 e to the power minus x minus 1. Am I correct or wrong? Yes? Correct? Now, can you get this result based on our advanced techniques? That's my point. Okay, you can ask me, sir, why I need this, I am getting this, but this is possible this way if you have only second order. If you have third order, fourth order, fifth order, nth order, you cannot do this way. Okay, it will be difficult. Then our technique will be useful. Okay, and so how to do in our way? So this result you remember 2 e to the power minus x. Okay, minus x to the power 2x. I think I am correct. Yes. Okay, you can also verify if you take, if you put x equals to 0, what you are getting? 2 minus 1, 1. If you put dy dx, it is minus 2 and plus 2, 0. This 0, this actually coming time. So, excellent. Now, the solution in the eigenvalue and eigenvector, the solution should be x bar, which is summation alpha I0 e to the power lambda I t u I bar. Okay, what are ui bar? What is your matrix? Matrix is 0, 1, minus 2, minus 3. Okay, so a minus first eigenvalue is minus 1, right? I am putting lambda 1 u1 equals to 0. What are you getting? Minus 1, 1, minus 2, minus 3, plus 1, right? u1, 1, u2, 1 equals to 0, 0. Am I correct? Yes. So, what are you getting? Minus 1, 1, minus 2, minus 2, u1, 1, u2, 1 equals to 0, 0. Am I correct? So, how to, what the, see, this is eigenvalue problem, determinant of a minus lambda 1 has to be 0. So, then you do the row echelon from 1 row has to be 0. So, how to do row echelon from here? R2, 1 equals to R2 plus 2R. R2 plus 2R. So it is minus 1, 1, 0, 0. Am I correct? So it is u1, 1, u2, 1, which is 0, 0. So you got only first equation independent. You got first equation independent. What is that? Right? Okay, thanks. I do a lot of mistakes. Sorry for that. Minus e1, 1 plus e2, 1 equals to 0. Any other problem? Pardon? It is minus 1. Oh, minus lambda. So, this what's the eigenvalue? Minus 1 and 0. Eigenvalues are what here? Okay, should be plus 1, right? This is okay? Okay. Now it's fine. Am I correct? Sorry for that. Please check out because I am just doing an episode of silly mistakes. Why buzzing? Any problem? Okay, is that correct? So now, as we do u2, I put alpha. Okay. If I say u2 equals to alpha, what is u1 alpha? u1 1 minus alpha. That is the way we do the null space. This solution belongs to null space. Right? This solution belongs to null space. So what is the u1 what? Which is alpha minus 1 plus 1. Am I correct? Or is it wrong? It's correct. Similarly, what is u2 what? Can you tell me quickly? Alpha I am putting 1. Eigenvectors, I just put 1. Anyway, it is non-unit, so I can always put alpha equals 1. u2 bar is what? How much? So this is corresponding lambda 1 is minus 1, right? Yeah. Same thing now I do what? u2 bar. I will do the calculation. Lambda 2 equals to minus 2. Right, yes. Lambda 2 equals to minus 2. Minus half. Is that correct? All of you agree with this? Yes? Yes, you are agreeing. Anybody else agree? You are agreeing. Fine. Now, matter is not ending here. Why? Because if you look at your solution, you got this one. You should be very happy. E to the power lambda I is there also, which is -2 and -1 and -2. But this guy is not evaluated. And how to evaluate this guy? We have already seen it. Alpha I0 is nothing but x bar 0 Vj bar. So you have to find out the eigenvectors of the adjoint system. Okay. So what is the adjoint system? The real matrix A transpose. A transpose is what? 0, -2, 1, -3. We can check it out. Eigenvalues are how much? Should be same. Check it out. -1, -1. So A bar T minus lambda I B I bar equals to 0. Okay. So I want B1 bar, I want B2. And now you can see that your B1 bar, B2 bar has to be such that U1 dot B2 has to be 0 and U2 dot B1 has to be 0. The inner product of U1 B2 equal to 0, inner product of U2 B1 equals to 0. Otherwise it's a problem. So I want your answer. And I should not ask whether the answer is correct or wrong. I immediately verify in the board whether you are giving me correct answer. Okay. So I will not do the calculation because simple eigenvalue problem. I don't want to do it. You can do it very fast. You can do it very fast. So can you please tell me the answer? Can you please tell me the answer? What is this? How much? 2, 1 for lambda 1 equals to -1. Okay. Next, I immediately verify -half into 2 -1. Yes, you are correct. You are very correct. And if you look at U1 and B1, it should not be 0. Of course, it is not becoming 0. It is -2 and -1, -1. Just come. It should not be 0. It is 0, something must be wrong. So now we will be doing for lambda 2 equals to -2. 1, 1. Pardon? 1, 1. So if you now look at U1 and B2, which is -1 and 1 is becoming 0, and -half and +1 it is -half. So these two are acceptable eigenvectors. Yes, correct. Have you done it? Okay. Very good. So so many things have been done. So now we have the right situation to calculate alpha 1 0, which is x 0 b bar. I will not put double bar because it is a real quantity, and we have u0 sorry u1 b1 bar. Am I correct? This formula? Okay. Now x bar 0 is how much? It is 1 0. B1 bar is 2 1. U1 bar is -1 1, and B1 bar is 2 1. So basically, what we do? It is if you have to. I am putting dot here. Actually, this transpose with this and this transpose with this. How much you are getting? How much you are getting? Alpha 0 minus 2. Alpha 2 0. -2 is acceptable, right? Second name, sure. Or what is working with you? What's your name? Naveen. Okay. Naveen. So tell me alpha 2 0. Tell me alpha 2 0. Yes. +2. Is that correct? Alpha 1 0 is -2. Alpha 2 0 is +2. Yes. Okay. So now, how to get the solution? X bar alpha 1 0 e to the power lambda 1 e u1 bar alpha 2 0 e to the power lambda 2 u2 bar alpha 0 is how much? -2 e to the power lambda 1 is -e, and then u1 bar. Remember that this t is replaced by small x bar is replaced by y and z, because I am putting everything in terms of dx dt goes to x. Alpha 20 is plus 2 e to the power minus 2t, and what is u1 bar? u1 bar is, what is that? Minus 1, and this is minus half 1. So it is your y vector and z vector. So you got the solution, not only y, you also got solution for z also. Okay, so now if you see that minus 2 minus minus plus 2 into minus t, 2 into minus t, okay, and then 2 and minus half, it is minus 1, it is for minus 2t, t is replaced by x, but advantage of this thing is you got derivative solution also. Here you have to do separate. Okay, so with this I think I stop, but this problem if you want to be included in the first quiz, I will be happy. If it is your permission, I wanted up to this to be included in the first quiz. If you say yes, I will be happy, otherwise I can go ahead. Now it is your choice. Yes or no? Yes. Okay, majority is I am saying yes. Any no's are there? How many no's? I have to also consider that one, because they are also my friends. Both are my friends. Yes also my friend, no also my friend. How many no's are there? So based on that I will see how many no's. No no's I can see. Okay, so up to this I can access. I can give this kind of school level problem, right? On a school level problem I will pick up. Okay.